Hello everybody. My name is Matt Wood. I'm the Technology Evangelist for Amazon Web Services. I cover Europe, the Middle East and Africa. And I just want to thank you all very much for coming and listening to us today and allowing me to talk in English. Your English is almost certainly better than my Italian, so thank you for that. So it's my job to come to talk to smart people such as yourselves about cloud computing in general, about Amazon's cloud platform specifically, and that's what I'm going to do today. So, as some of you may be aware of Amazon and some of our history, Amazon is perhaps best known for Amazon.com and Amazon.co.uk, .it, .es, our range of e-commerce sites. Actually, just a quick show of hands. Can you put your hand up if you have an Amazon account for buying books or DVDs and everything else? Okay, most of you, that's good. So actually that's just one component of our business. At our heart, Amazon is a technology company that just happens to run a bookstore. And our e-commerce line is really just one aspect of our business. So we have our consumer business, which is the Amazon e-commerce sites. We have our merchant or seller business, which allows other people to take advantage of some of the operational expertise that we've built up in operating e-commerce sites. Right from managed platforms for people like Timex and Samsonite, all the way through to individual sellers who sell directly to customers who arrive at the Amazon site. And the third aspect of our business is our developer business, Amazon Web Services. And it's that I'm going to talk about today. So a lot of people ask me, what is a bookstore doing selling cloud computing services? And so I thought I'd just touch on, by way of introduction, how Amazon arrived at operating a developer business. And the truth is that we built out decades of experience in the operations, the management, and the sort of scale that's necessary to run an e-commerce or technology platform such as Amazon.com. And probably about 10 years ago, we started offering programmatic API-level access to some of our catalog metadata. So we allowed developers to use the data from our catalog, album art, names, book names, ISBN numbers, and all the rest of it, and use those for whatever they wanted. And what we saw was an unexpected level of innovation. We saw developers taking this information from our catalog and doing remarkably innovative things for it, for their own businesses and for their own customers. And so we had a blinding flash of the obvious. What would happen if we took the same API-level access and applied it to our expertise and operational skills in operating data centers? And that's exactly what we did. So what I'm going to talk about is Amazon Web Services, what we call web services. A lot of other people have come to call cloud computing. We've been doing this about 5 years now, so we're 5 years young. Our first service, the simple storage service, launched about 5 years ago. And that's evolved into a range, a platform of compute services, storage services, database services, and a collection of orchestration and automation tools to help you piece all of these building blocks together. And of course we have support offerings as well. So no matter whether you're provisioning compute infrastructure or using storage, all of our services have a core set of common characteristics. The first is that they're all available. And what I mean by available is that they're all available on demand. So you can go up onto our website, you can log in with your existing Amazon credentials and start provisioning and working with these services straight away. You don't need to come and talk to myself or any of the rest of the Amazon team to start taking advantage of some of these services. They're just there at the end of an API call or the end of a couple of clicks on the web. And they're also available elastically. So you can use as little or as much of them as you wish. You can start off by using just a single K of storage and scale all the way up to petabytes. The same with compute as well. So availability is very important, both the availability of the resources to start with and the availability of scale and the elasticity that provides. They're also available at low cost. So everything is pay as you go. All our customers start at $0 and they grow as they use more services. So it's pay as you go. And you can think of this very much like electricity. In the same way as businesses no longer run their own electricity generator, electricity is now delivered to your house as a utility, so these compute services are delivered to you as a utility. And much like when you start plugging in your laptop or turn the light on, that's the point when you start paying for your electricity. The same is true with these compute services. So as soon as you turn on that first server, as soon as you write the first piece of data to our storage services, that's when you start paying for them. And when you terminate that instance, when you remove that data, you stop paying for it, just like you do when you turn out the light. So there's no contracts, there's no subscriptions or anything like that. You're free to come and go as you please, and there's no capital expenditure. So there's no upfront investment that you need to make to use any of these services. And as I say, you only pay for what you use. And they're designed to be very, very flexible. So you can bring your existing tools and your existing skill set, your existing team skills, and bring those up into the cloud. So whether you are running on Windows or Linux, whether you're running on MySQL or Oracle, wherever you've already made an investment to build up those skills, you can take those skills and bring them up into the cloud. And whilst our services are designed to work together, so our compute is physically co-located with our storage, for example, for low latency access, there's no requirement to use them together. So you can use the storage without using the compute and vice versa. And the idea is that the platform can grow with you. So while you might start out using just storage services, you can add to that compute services, analytics services, database services, as and when you need them. And of course, you only pay for them when you start using them. So availability, low cost, and flexibility are the sort of core characteristics that I think define cloud computing. So how are we doing? We've got hundreds of thousands of customers in 190 countries, which is pretty much all of them. This is a graph of numbers that I pulled out of S3. So this represents the number of objects that are stored in S3. S3 is the simple storage service, and what we call objects are really just files. And you can see the Q4 numbers, 2006 all the way to 2010, and then we're in Q4 now, so Q3 2011, where we're storing 556 billion objects in Amazon S3. So I'm no mathematician, but I know exponential growth when I see it, and I don't think we've yet reached the hockey stick portion of this graph. So 556 billion objects in Q3, and those are being accessed and transacted at 370,000 peak transactions per second. So this is a very high-scale service that a lot of people are using in a number of different ways, and I'll come on to some of those use cases in a second. So I can talk about technology all day long, and I'm quite happy to offline, but what's really interesting is how these services can help benefit your organization. So when we have a new idea, a new business opportunity, a new project that we want to work on, we want to take that idea and move as quickly as we can through to a functioning product that's in the marketplace. A process that you have to go through to deliver your idea to your customers, be they internal customers or external customers. Now the problem with infrastructure is that it introduces a huge amount of friction against this process. So there's a lot of heavy lifting that doesn't really have anything to do with the product that you're trying to launch. When we started to look at this internally, we found that our own development teams were using about 70% of their time on just undifferentiated work. So this is work in terms of delivering storage at high scale, delivering elastic infrastructure at scale, which really didn't have anything to do with our core competency. And so this was just 70% of time, which is spent on the undifferentiated heavy lifting of moving your idea to a product. When we started working with these infrastructure services, we saw that invert. So we saw 70% of time going from just overhead to 70% of time with our teams developing real business value for our customers. And our aim really is to reduce that as much as possible. We still want to provide the flexibility and the visibility where you need it, but we want to get the platform out of the way so you can focus back on your core competency and ultimately move your idea as close to possible as a product. And this moves IT from being a typical limiter to your business, to being a barrier or a constraint for your business, to being an accelerant. This makes IT become the momentum for your projects, the momentum for your idea, and move your ideas through to the product, through to market more quickly. So we want you to focus on your core competency. In the same way that you no longer run your own diesel generator around the back of your house. Are we okay? In the same way that you don't run your diesel generator anymore, because it really is just extra work, we want you to focus on your core competency and take advantage of some of the lessons that we've learned, take advantage of our operational skills in building out the infrastructure that your project runs on. So we want to remove this undifferentiated work that provides no real value to your businesses and ultimately provide additional agility to the teams that run on AWS. So this becomes a bit of a challenge. The challenges that infrastructure poses on new ideas, moving to product, moving to market, are really that they have very spiky requirements. Requirements that change over time, requirements that, as we see, are very, very difficult to predict and are highly changeable. You can have unpredicted usage and distribution volumes, whether you're delivering data, whether you're generating data, whether you are working with petabyte scale data sets. And then all of this requires a large upfront investment. So there's a lot of work to do just to get the money in place in order to be able to build out the infrastructure before you start doing any real work. And typically, infrastructure that you provision yourself has remarkably low levels of utilization. So there's computers that are sat not computing. There's disks that are not spinning, which you've already paid for, which you have to fix and all the rest of it. So with the AWS Cloud, we want to take some of these challenges and, as I say, turn them from being a constraint of your business and move them towards an accelerant. So where once projects might have seen spiky requirements, we provide elastic capacity. So if you'll forgive my business school 101 graph here, this is typically what a team will have to do in order to plan out capacity for a project going forwards. So this could be an internal project running an ERP system internally. This could be a social game running on a social network, you name it. But you have some level of capacity on the y-axis, some level of time on the x-axis, and you try and predict the capacity you're going to need based on the utilization of your service. And based on that capacity prediction, you try and make an investment against your capacity. So the green line represents your real capacity or infrastructure capacity. This could be storage or compute or whatever. And you end up with this step 2 approach with large changes in your capacity linked to large capital investment. And over on the left-hand side, we have the initial barrier to entry. This is money that you have to raise internally to even get started. Now, the problem with capacity against demand is that your real demand doesn't look anything like your estimation. It looks a lot more like this. So the red line is now the real demand. This is people really using your service internally, externally, from their mobile phones, from their laptops. And you see all the way on the left-hand side, we've got a big gap with that initial barrier of money that you had to raise that doesn't really represent. So this is over-provisioning. You've got computers here that you provisioned, storage that you provisioned, internally that you have to fix and cool and power and all the rest of it, which isn't being used. And just as importantly, on the right-hand side, where demand starts to outstrip capacity, this is business opportunity cost. These are customers that you cannot serve because your infrastructure isn't flexible and fast enough to respond to your business needs. So with elastic capacity, what we see is something much more like this, where you can adjust the capacity based on your demand. You can start all the way down at 0, so we remove that initial barrier of entry, and you can respond very, very quickly to the needs of your business and to the needs of your customers. So this is what we mean when we talk about elastic capacity. And we have elastic capacity for compute and storage and databases and all the rest of it. And as your demand starts to go down, of course, because you're only paying for what you use, you can reduce the capacity. Just as easily as you can increase it, and because you're only paying for what you use, there's a cost reduction. So every time you see a dip, that's a cost saving for you, whereas with a traditionally provisioned static infrastructure, that is, you're just wasting the opportunity there to save money. So we go to elastic capacity. In terms of unpredictable usage and distribution volumes, well, we have a highly scalable infrastructure. So a really good example of this is a company, Netflix. They do video on demand and DVDs through the mail in the US. Very, very large company. They had a problem with the launch of the PlayStation 3. They needed to be able to transcode 17,000 video on demand titles to a number of different formats so that they could get it ready for the launch of the Sony PS3. Now this, they couldn't really have predicted, right? They had some idea of when the PS3 was coming, but they didn't know for sure. But when it arrived, they knew they had to have the whole library ready for access. So what they did, they provisioned 1,200 Amazon EC2 instances. What we call an instance, you might call a server. So that's 1,200 servers provisioned, and they completed the whole transcoding process in just a few days. And they were 100% ready to launch for the PS3 launch. So that's Netflix there. And you can see just how spiky this use case is. You can see just how unpredictable their delivery of the content and the transcoding needs are. So this is some numbers very kindly provided by Netflix. They asked me to cover up some of the details. So these are summer 2010 numbers. Current production is much, much higher. And we've got a timescale of several months. And the number of servers or instances that are running moving into the many thousands. And you can see just how spiky the content encoding workflow is. It goes up very, very quickly, and you have these sharp drops. And right back at the left-hand side of the graph there, you can see it's much, much lower. Orders of magnitude lower capacity than they needed several months later. So being able to plan for that with traditionally provisioned infrastructure is extremely challenging. Every time they see a decrease in their needs, every time they see a decrease in demand, Netflix can just scale back their infrastructure and instantly they stop paying for it. So this is a good example of elasticity and scale being used to really drive a business for new business opportunities. Another great example is a startup called Animoto. Animoto run a service where you can provide some music and some of your photos, and Animoto will go away and create a very, very nice looking animation, a short video of a slideshow of your photos. Here's their usage graph. So you can see they are pottering along nicely with a relatively low number of servers. So again, we have servers up the side and time along the bottom. And you can see this inflection point just around the 16th of April. And that's the point at which they launched their Facebook app. So they knew that they had a huge audience in the social network, and they wanted to take advantage of it, and they launched that social application. It did extremely well, and they were able to scale up to WhatsApp. 3,500 instances in just a couple of days. So the scale was there when they needed it, and this is a small team, a small company, that didn't have huge amounts of venture, didn't have a huge amount of capital in order to be able to maximize on these customers. But with the cloud, they were able to open up this opportunity and grow their business forwards. So we also talk a little bit about large upfront investment. So obviously, Animoto took advantage of the fact that they could scale up to this enormous number of servers straight away without having to provision for that ahead of time, not knowing how successful their social application was going to be. But we can move from capital expenditure to operational expenditure for all of our customers. So a really good example of this is Zynga. Zynga, some of you may be familiar with. Zynga make this wonderful game, Farmville, which runs on social networks and iPhones and iPads and whatever else. And another similar company, Playfish. Playfish make social games on social networks, recently acquired by Electronic Arts. They're now EA Mobile, and they're built 100% on AWS. And the thing here is that with social gaming companies like to launch a lot of games because they don't know which one's going to be successful ahead of time. So they don't want to make a large capital investment on a game that may not be successful. So here they can launch the games, scale up the ones that are successful, and move on from there. So traditionally, if they wanted to provision the infrastructure to run games like Sims 3, which is currently being run on Playfish, they would have to buy a huge IT infrastructure. They'd have to run the data centers, hire people to manage it. They'd have to negotiate the contracts and the support contracts and the development contracts. They'd have to manage all of that when it was actually up and running. And eventually, when the hardware reached its end of life, went out of support, they'd have to upgrade and go through the whole thing again. Now, you'll notice that none of this has anything to do with building games and building out a business. This is the undifferentiated work of taking an idea to market that I was talking about. In the cloud, there's no need for this capital expenditure. You have a much faster time to market. You can build out much higher availability applications, be they social applications or business line of sight applications. You can have large cost savings, and again, you can focus back on your core business. So to help with this, whilst we have this operational model, we also like to innovate on behalf of our customers in terms of pricing. So one thing that we did inherit from our cousins over in retail was a real need to innovate on behalf of our customers and to continue to lower costs. So we do this by some different pricing models. So we have on-demand pricing. This is the price that you pay if you just provision a new instance and start using it. We have reserved capacity. This is perfect if you want to run a server or an instance for a set amount of time. So if you're running a database server, basically more than 50% of the time, then you put a small upfront one-off payment in place, and that reserves that capacity and gives you a lower hourly rate for running that infrastructure. So it's typically between 20, 30, 40% cost saving associated with that. And we also have spot pricing. So spot pricing allows you to set the price for the compute that you want to pay. So we look at our capacity each and every hour, and we recompute the value of that capacity based on demand, and we allow customers to bid against it. So you can set a bid price, and when the spot price comes beneath your bid price, we'll provision the infrastructure for you. You can start using it. The deal being that if the spot price goes above your bid price, we'll take that capacity back. So you do need to architect for the fact that interruption can occur. But this is an excellent way of provisioning very large amounts of compute, probably about 60% saving over on-demand pricing. So spot pricing is a very effective way for batch processing, doing analytics, and we have a number of customers that are being built entirely on instances provisioned on the spot market. And this is some of the graphs that you can learn. So this is the spot price fluctuation for an instance size on the Elastic Compute Cloud over a period of time. And you can pull that out either via an API or we draw these nice graphs for you. Cycle Computing used exactly this approach to provision 30,000 cores for a large analysis job. And for that we charge them just $1,279 an hour. So you can pull up remarkable amounts of compute, remarkable amounts of capacity only when you need it and be charged a very, very small amount. We also have some nice innovation in place for some enterprise applications such as Oracle. A lot of the Oracle applications such as Fusion Middleware, Oracle Database 11g, the e-business suite are certified for production use and support on EC2. We also support it on our relational database service, which allows you to run a managed Oracle or MySQL service on the cloud. And to help with this, we have licensing, which is built into the hourly price of the instance that you run. But if you have existing licensing agreements with Oracle in place, existing enterprise agreements, you can just bring those up into the cloud and we'll knock that additional licensing cost off your hourly rate. Certified and certified. We do the same thing with SAP. So rapid deployment solutions, business objects. You can use your existing licenses or you can pay for those licenses as you go on an hourly rate on EC2. So we move from CapEx to OpEx. Now we have low utilization. Well, we can solve that by only paying for what you use. So no matter what your utilization is, you can dynamically adjust the amount of capacity available to you, and you can dynamically change the amount that you're willing to pay using spot pricing. So back in to take advantage of tools exactly like this. This is a graph of utilization for a Monte Carlo simulation of risk analysis. So you can see here the scale that they need, but you can also see the spikiness. So they really have no utilization at the weekend when nobody's in the office. They have no utilization in the evenings when nobody's working. But they have very, very high levels of utilization. So had they wanted to provision this internally, what's that, 1,500 cores, they'd have had to have been running 1,500 cores solidly, cooling, power, and all the rest of it, for really what is an extremely low level of utilization, but has these very, very large spikes in it. The trouble was that even with Bank Inter, Bank in Spain, if you're not familiar, Bank Inter actually had a problem in addition to this, that they didn't have the internal capacity in order to be able to respond quickly to the market. So it used to take 24 hours to run the Monte Carlo simulation. When we removed that capacity gap, when they moved up into the cloud, they were able to run that in just 20 minutes. So the elasticity, the pricing, and the spikiness of the use case turned out to be a great fit for them. So the third and final thing I want to talk about really is security of the cloud. So this is a sort of a hot topic, and so I want to spend some time, just a couple of minutes, discussing how Amazon sees all this. So this is maybe the most important slide I'm going to use today. In terms of security, Amazon operates a shared responsibility model. So whilst we undertake to secure the infrastructure, that's basically everything from the foundations of our data centers all the way up to the hypervisors of our virtual machines, it's our customer's responsibility to secure the operating system which runs on top of it, the application which is running on that operating system, and the data which is housed within the application. So we share the responsibility of securing the architecture and the applications and the data that are held within them with our customers. And it's very important to understand this division of responsibility on the AWS cloud. So we undertake to secure the infrastructure, as I said. We have requirement-based access to our physical infrastructure. Nobody gets anywhere near our cages without having a very good reason. And we audit those reasons both internally and externally. We have high levels of certification, as you would expect, to back up these auditing processes. So we are ISO 27001 compliant, we're SAS 70 Type 2 compliant, and we're also PCI DSS Level 1 compliant. So again, this is a really good example of shared responsibility. PCI DSS Level 1 is a payment processing standard, and whilst we are certified for the infrastructure, if you want your application to be certified and your full workflow to be certified, you need to certify your application on top of that infrastructure as well. So the shared responsibility model there. And here are some of the control objectives that we certify against. So our own internal security organization, how we handle a chain of command internally, employee lifecycle, background checks, the logical and physical security of our infrastructure, secure data handling, the environmental safeguards, fire suppression systems, change management, incident handling, data integrity, and availability and redundancy. So we have, as of this morning, 5 different regions of data centers. Over on the East Coast and the West Coast of the US, our data centers in Europe are in Dublin, and we also have data centers or regions over in Asia Pacific, in Singapore and Tokyo. And each of these regions you can think of as a mini cloud. They're made up of multiple availability zones, so that are comprised of more than one data center, which are redundantly powered, redundantly connected. They're on separate fault lines, physically separated and all the rest of it. And we use these availability zones to maximize the reliability and availability of data housed on the Amazon cloud. So for S3, for example, objects written to S3 are mirrored across these availability zones, and so that's why S3 is able to be tolerant to 2 simultaneous failures and offers 11 nines of data durability. So we do that through the availability zones in these regions. As of about an hour ago, I'm very pleased to announce that we have a new 6th region. So we have a new region over on the US West Coast in Oregon, and this is good low latency access for customers on the West Coast, and it's also very, very cheap. So US West announced about an hour and a half ago. So availability zones, it's important to understand how they work. Customers can use these for data reliability and availability, but also to build out highly available applications. So you can deploy your applications across availability zones to take advantage of the fact that they are redundant and highly available. Importantly, whilst we might mirror data on S3 between these availability zones, we don't mirror them between regions. So data always stays local. And I want to get away from this idea that when you put data up into the cloud, you somehow lose control over it. All of our customers retain full ownership and control of the data, and we don't mirror it between regions. You can do it yourself if you want, but we won't do it for you. And this is very important for certification and regulatory reasons where you have data which you may not want to be mirrored across to the US. So data stays local. Data placed in European data centers will stay there. We also have data access control for privacy and for setting who and where you share your data with, and identity and access control, which can be federated against your enterprise identity systems. And we have a service called the Virtual Private Cloud, which gives you full control over the network topology that you run in the cloud. So you can create public and private subnets, you can put full network access control lists in place, you can bring your own IP addressing, and you can extend your existing IPsec virtual private network up into the network isolated region on the Amazon cloud. And in addition to that, we also have dedicated instances. So you can flag any instance that you're using and mark it for only for your use, and dedicated direct connections to our data centers. If you want to know more about this, I've really only scratched the surface given the time, but you can read 2 great white papers, aws.amazon.com/security for our security center. These are well worth the read. They're written in plain English. They're very simple, about 15 pages each. You can download them, put them on your Kindle and read them on the train. We have a risk and compliance white paper and also an overview of our security processes, which goes into much more depth about the certification that I mentioned. And all of this and more is available on our website at aws.amazon.com. And I'd like to thank you very much for your attention. Thank you.